Hi there, Joshua here. Right, area. It's actually been a strange kind of... Hang on a sec. It's actually been a strange kind of week, a bizarre kind of week. I actually burnt myself picking up a rectangle this week. Bit embarrassing. Yeah, I forgot the corners were 90 degrees. So, yeah. Let's get on with the lesson. Right, so we're going to be doing area today. So we're going to be finding the areas of some flat shapes, some two-dimensional shapes, specifically rectangles, but also some triangles as well. Now the area of a shape is just basically how big it is. It's just a measure of its size. And we normally measure area by counting squares. So you could think of area as just the number of squares the shape covers, or the number of squares that would fit inside it. Yeah, so of course squares can be any size, so we need to be clear about what size squares we're using when we talk about area. One square we use often is squares where the sides are all 1 centimetre. This is called a square centimetre. A square this size is called a square centimetre. And we often use these squares when talking about area. I've just abbreviated centimetre there. So let's say you had a shape made out of these squares. Just a very rough sketch. Let's say you had a shape like that, made out of square centimetres. So what would you say the area was? Well, you just count the squares. So there are 4 of them. So we say the area is 4 square centimetres. And the symbol we use for square centimetres is the centimetre symbol, like that, but with a little 2. So we'd write the area like this, 4 square centimetres. Let's do another shape made out of square centimetres. So what would the area of this shape be? Well, again, you just count the squares. This time there are 6 of them, so the area is 6 square centimetres. Now, of course, you could use squares of any size, so you could use bigger squares to measure area, like square metres, perhaps. A square metre is just a square where all the sides are 1 metre. Of course, a square metre would be much bigger than this in real life. This is just a sketch. But yeah, if the sides were all 1 metre, then this would be a square metre. A square metre. And suppose the shape was made out of these bigger squares. Suppose it was made out of square metres. Again, this is just a rough sketch. So a shape like that. So what would the area of this shape be if it was made out of square metres? Well, again, you just count the squares. There are 4 of them. So the area is 4 square metres. And the symbol for square metres is M for metres with a little 2. So 4 square metres. Right, let's move on to the shapes on the grid. Let's assume that all the squares on this grid have sides 1 centimetre. So in other words, let's assume that all the squares are square centimetres. So they're all square centimetres. So what would the area of shape A be? Well, again, you just count the squares inside the shape. So 1, 2, 3, 4, 5, 6. So the area of shape A is 6 square centimetres. And shape B, what's the area of this shape? Well, there are 2 whole squares inside the shape and also 2 half squares. And they together make another whole square. So the area is 3 square centimetres. 3 square centimetres. Right, let's move on to rectangles now. So I've got a rectangle drawn on the grid. We're going to find the area of the rectangle. Let's still assume that all the squares on the grid have sides 1 centimetre. Let's just write down the length and width of this rectangle. So this side, if you count, is just 4 centimetres. And this side is 5 centimetres. Let's find the area of the rectangle now. Again, just by counting the squares inside the shape. I'm going to do it row by row. So there are 4 rows with 5 squares in each row. So the total number of squares is just 5, 10, 15, 20. So the area of the rectangle is just 20 square centimetres. It covers 20 of these squares. Now, a lot of you may know a quick way of finding the area of a rectangle. The quick way to do it is just to multiply the length and the width together. So 4 times 5 or 5 times 4. That's a quick way of finding the total number of squares, which is 20. So the area of this rectangle is 20 square centimetres. Let's do a few more. So let's say this side is 3 centimetres and this side is 6 centimetres. So what's the area of this rectangle? In other words, if it was drawn on the grid, how many squares would it cover? How many square centimetres would it cover? Well, again, the quick way of finding the area is just to multiply the length and the width together. So 6 times 3 is 18. So the area is 18 square centimetres. And I could show you that it's 18 by splitting it into square centimetres. If I was to draw the individual square centimetres, there'd be 6 along this side, and there'd be 3 going down. So you could have sort of 6 rows of squares, sorry, 6 columns of squares and 3 rows. And you can see the total number of squares is just 3 lots of 6, or 6 lots of 3. It's 18. But the quick way to find the area is just to multiply the length and the width. Let's do a couple more. Let's say this side was 4 centimetres and this side was 7 centimetres. What's the area of this rectangle? In other words, how many square centimetres could this rectangle be split into? Well, again, the quick way to find the area is just to multiply the length and the width together. So 4 times 7 is 28. So the area is 28 square centimetres. And again, I could split it up into individual square centimetres. You could get 4 along this side and 7 going down. So there'd be 4 columns of squares and 7 rows of squares. So each of these squares is meant to be a square centimetre. And yeah, the total number of squares is 28. There are 7 lots of 4 if you add them row by row, or 4 lots of 7 if you add them column by column. So there are 28 squares altogether. Right, let's just do a couple more. So I'm not going to split this one into squares. Let's say this side is 5 centimetres and this side is 9 centimetres. What's the area of this rectangle? In other words, how many square centimetres could this one be split into? Well, again, the quick way of finding the area is just to multiply the length and the width together. So 5 times 9 is 45. So the area is 45 square centimetres. And just one more. Let's do the measurements in metres this time. Let's say this side is 4 metres and this side is 3 metres. So what's the area in square metres this time? Well, again, it's the same as before. You just multiply the length and the width together. So 4 times 3 is 12. So the area is 12 square metres. 12 square metres. And again, I could split the shape into individual square metres. If you imagine doing that, there'd be 4 square metres. You could get 4 square metres along this side, and you could get 3 square metres going down. So there'd be 4 sort of columns of squares and 3 rows. And you can see that there are 12 square metres altogether. Just 4 lots of 3, or 3 lots of 4. That's 12. So to summarise, to find the area of a rectangle quickly, you just multiply the length and the width together. Right, I'm going to move on to triangles now. I'm going to start with right-angled triangles. A right-angled triangle is just a triangle with a right angle, with a 90-degree angle. So I'm just going to mark it like this to show it's a right angle. And let's still assume that all the squares on this grid have sides 1 centimetre. Let me write down also these 2 lengths. So if you count, this length is 3 centimetres, and this length is 4 centimetres, and we're going to try and find the area of this triangle. Now, if you haven't done triangles before, it's not going to be it might not be obvious how you find the area. If you imagine counting the squares, it'd be difficult because there are lots of bits of squares inside the shape, and it's not obvious what they make all together. But if you have done this topic before, you might know a trick for finding the area of a triangle like this. You basically turn it into a rectangle. You connect these 2 corners to form a rectangle by sort of drawing lines parallel with these 2 sides to form a rectangle. And this rectangle is actually twice as big as the original triangle. because this new triangle here is just a copy of this one. It's just a rotated version of it. So all you have to do to find the area of the original triangle is just find the area of the rectangle, which is twice as big, and then halve the answer at the end. So that's what we're going to do. So the sides of the rectangle are just 4 and 3. So the area of the rectangle is just going to be length times width, 4 times 3, which is 12. So the rectangle has an area of 12 square centimetres. Covers 12 of these squares. So what's the area of the triangle going to be, do you think? Well, it's half as big, so it covers half as many squares. So the area of the triangle is just half of 12, so it's 6 square centimetres. So the rectangle covers 12 squares, the triangle covers half as many squares, it covers 6. Right, let's do a couple more examples. So let's say this is 4 centimetres and this is 5 centimetres. Right, let's find the area of this triangle. Now again, I can sort of form a rectangle that's twice the size of the triangle. You just connect these corners, not the right angle. You always connect these corners by drawing lines sort of parallel to these two sides to form a rectangle that's twice as big as the triangle. So the area of the rectangle is just 5 times 4, just length times width, which is 20. So let's put R equals 20. Just using R for area of rectangle. So the triangle is half the size, so you just halve 20, which is 10. So the area of the triangle is 10 square centimetres. Let's do a couple more. So let's say this side is 3 centimetres and this side is 7 centimetres. Notice each time I'm giving you the lengths of the two sides that form the right angle. You need to know those two lengths to be able to work out the area of the triangle. Yeah, so what do you think the area of this triangle is? Well, again, I'm going to draw a rectangle to help. Again, from these two corners, you sort of connect them. So not the right angle, you connect these two corners by drawing lines parallel to these two sides, as before. You get a rectangle that's twice as big as the original triangle. So the area of the rectangle is just length times width, so just 3 times 7, which is 21 square centimetres. And the triangle is half the size of the rectangle. So you have to halve 21. Half of 20 is 10. So half of 21 is 10 and a half, 10.5, all right, square centimetres. And I'll just do one more down here. So let's say this side is 8 metres and this side is 5 metres. So we're in metres now, so we want to know the area in square metres. So what do you think the area of this triangle is? Well, again, drawing a rectangle that's twice the size, I'll just mark these two corners. And again, I'll just draw lines parallel to these two sides to form a rectangle twice the size of the triangle. The area of the rectangle is just 8 times 5. So that's the length and the width. So 8 times 5 is 40 square metres. So the area of the rectangle is 40 square metres. So the triangle half the size, just have to halve that. So the area of the triangle is 20 square metres. So to find the area of a right angled triangle, you just form a rectangle that's twice the size. You work out the area of the rectangle and then you halve the answer. Right, so I'm going to stop here. So that's the end of lesson 1 on area. I am going to do another lesson on area. I think I'll call it lesson 2 on area. So in this lesson we were just finding the areas of right angled triangles. Next lesson, lesson 2, I'm going to be finding the areas of triangles without right angles. So what I'm going to do now is I'm going to put some questions at the end of this video based on what we did today. For anyone who wants a bit of extra practice. As I always say, the best way to improve at maths is to watch my videos, obviously, and try practice questions as well. So I'm also going to put the answers after that, so you can pause the video, have a go at the questions, and then look at the answers in that order. Right, here are the questions. Bye.